Very good morning. So, in this video, I am explaining about the camps and followers. So, presenting by Kumaran, HOD, Mechanical Engineering Department, RR Polytechnic, Bangalore, 90. So, let us start with the introduction of CAM. So, what do you mean by CAM? A cam is a machine element having a curved outline which transmits the rotary motion as a predetermined motion into the other element called as follower. What do you mean by cam? Means a cam is a machine element having a curved outline which transmits the rotary motion as a predetermined motion into the other element called as follower. So that is the actual definition of cam. So the cam majorly plays a very important role in automatic machines such as in functioning of automatic such as printing presses, textile machinery, gear cutting machines, automobile engines. In all these sectors, the cam applications can be observed. So mainly if you see in automobile engines, the cam are majorly used to open and close the valves of the cylinder head. So with the help of the cam with the follower arrangement. The classification of cams, you can see there are the classification of cams based on their physical shape. One is disc or plate cam. Mainly the disc cam has an irregular contour to impart a specified motion to the follower. Means mainly it will provide the rotary motion as a oscillatory or responding motion to the follower. Here in a disc or plate cam, the follower it will be moves in a plane perpendicular to the axis of rotation of camshaft. That is about disc or plate cam. Second one is cylindrical cam. So the cylindrical cam, it has a groove on its cylindrical surface. Through this groove, the follower it consisting of a roller. So roller it follows the groove, and the follower it will be moves in a parallel to the axis of rotation of the cam. So that is about the cylindrical cam. The third one is translating cam. The translating cam is a contoured or a grooved plate sliding over a guiding surface. So means this the translating cam it will be having a contoured means any of the shape it will be making over the guiding surface or a grooved plate. So it will be sliding over the guiding surface. The translating cam it can reciprocate or oscillate. The types of cams, you can see the images one by one. So the first one, what you can see here, so this is a plate or disc cam. So the disc cam, it will be having an irregular contour. It imparts a specified motion to the follower. So here you can see the follower, it will be moves in a perpendicular to the axis of rotation of the cam. So if you observe here, the follower, it will be reciprocates in the guides when the cam, it rotates. So means the follower axis, it is perpendicular to the axis of camshaft. So both the figures are plate or disc cam. Here it is having oscillatory motion. Here it is having exploding motion. So this is a plate or disc cam. The second one you can see, this is a cylindrical cam. So in the previous slide, what I explained about the cylindrical cam, it will be consisting of a groove over the cylindrical surface. Here you can see this is a cylindrical groove over the cylindrical surface. The roller, it will be rolls over the with this groove, and the follower, it will be moves in a parallel to the axis of rotation. Means the follower, it's subjected to oscillation motion. So in that condition, the roller, it will be rolls over this groove. So the third one is translating cam. So the translating cam is a contoured or a grooved plate sliding over the guiding surface. So this is the guiding surface. Here you can see it will be subjected to sliding over the guiding surface. It will be subjected to sliding motion over the guiding surface. So here the translating cam follower, it may be subjected to oscillatory. So the figure A, it is subjected to the follower, it is having oscillatory motion. Here the figure B, it is showing the follower is having exploding motion. So this is translating cam. Next, I'm explaining about the classification of followers. The followers can be classified into based on the headings. First one is based on surface in contact. One is knife edge follower. Second one is roller follower. C, flat face follower or mushroom follower. D, spherical faced follower. Second one is based on type of motion, oscillatory or rotating follower, translating or reciprocating follower. Next, based on the line of movement or line of motion, radial follower, offset follower. So these are the classification of followers. In the next slide, the classification of followers, the images are displayed. So let us discuss one by one. So the types of followers, the first one is based on the surface in contact. So here you can see based on the surface in contact, the followers are, first one is knife edge follower. The figure 8 shows the knife edge follower. When the contact end of the follower having a sharp edge, it is called a knife edge follower. So here between the surface contact, here it is having a sliding motion. A sliding motion, it will be exist over the point of contact between the cam and the follower. Here, because of a small point of area of contact between the contacting surfaces, so wear, it will be more. So it will be resulting in excessive wear. So coming with the second one is roller follower. When the contacting end of the follower, it is a roller, then it is called a roller follower. So here the rolling motion exists between the contacting surface between the cam and the follower. Because of rolling motion, so resulting wear, it will be reduced because of rolling motion. So this type of follower can be seen in oil engines, gas engines, aircraft engines, where the space application will be more. So it will be having more space, such as stationary oil and gas engines or aircraft engines can be seen this type of follower. The figure C, what it shows is flat face follower. So when the contact end of the follower is perfectly flat face, then it is called flat face follower. So here the sliding motion, it will be exist between the contact surface between the follower and the cam. This type of follower can be seen in automobile engines, where the space applications is very much limited. There we can see the use of flat face follower. So means in order to open and close the valves of automobile engines in synchronization with the motion of piston. So in such cases, the flat face followers normally used in automobile engines. The figure D, what it shows, this is spherical face follower. When the contacting end of the follower is a spherical end, it is called a spherical face follower. When the flat face followers, it's used in automobile engines, it will producing a high stresses. In order to minimize the high stresses, the flat face follower is machined into a spherical shape. Then it is called spherical face follower. So this is about the based on the surface in contact. The second one is based on the type of motion. So that is oscillating follower. So the figure A, what it shows, this is oscillating follower. When the cam rotates uniformly, the rotary motion of the cam is converted into predetermined oscillating motion. It is called oscillating follower or rotating follower. So here you can see in the figure, so when the cam rotates about its shaft, so the follower, it is subjected to oscillating motion. The second one is reciprocating follower. The rotary motion of the cam is converted into reciprocating motion, or when the follower reciprocates in the guides, the cam rotates uniformly. It is called translatory follower or reciprocating follower. So the figure B, what it shows here, this is reciprocating follower. Next, based on the line of motion, so the followers, it is classified into one is radial follower. Radial follower means, so here the figure what it shows, this is called as a radial followers. So when the line of moment of inline followers passes through the center of camshaft, it is called offset. It is called radial followers. Means the axis of the follower, when it is passing through the axis of the cam's shaft, it is called inline followers. Means the line of movement of inline followers passes through the center of camshaft, then it is called radial followers. Offset followers, the line of movement is offset from the center of camshaft, then it is called offset follower. So the figure here what it shows, this is offset followers. Or another way we can also define, the axis of follower is offset from the camshaft center, then it is also called as offset follower. So this is about the classification of followers. Hope you are all enjoyed the video. So after watching my video, subscribe my link and leave your valuable comments for the betterment of my upcoming video. Thank you.